All right, what we're going to do now are compound inequalities. There's two kinds. One of them is where your x term is in between two inequality symbols, and you have these numbers on the outside, okay? This is going to be solved the same way we would solve an equation, only we have three parts. Instead of saying what you do to one side, you do to the other, what you say is whatever you do to one, you have to do to all three of the parts. We have a denominator of 5, so we know that we want to multiply by 5. We want to cancel the denominator. To cancel a denominator, you multiply by the denominator. So 5 times. 5 times negative 9, that's negative 45. Bring down the symbol. 5 times this fraction, we have 5 in the denominator, and therefore all we do is we just keep the numerator. 4 minus 3x. Less than 5 times 7, that's 35. Okay? Now, we want to get rid of this 4 here. So we're going to subtract 4, subtract 4, subtract 4. Cancel. Negative 45 minus 4 is negative 49. Bring down the symbol. All we have left here is minus 3x. Bring down the symbol. 35 minus 4 is 31. We want this x to be by itself, so we want to divide by negative 3. Well, if I divide by negative 3 here, I have to divide by negative 3 here, and I have to divide by negative 3 here. Negative 3 here, this is going to cancel the negative 3, and all I'm going to have left is the x. But I divided by a negative number, so I have to reverse both of the signs. Look at that. Now, negative divided by a negative, that's a positive. We have 49 over 3. 31 divided by negative 3, that's a negative, so negative 31 over 3. But look, this is weird. Again, we want the x in the middle, but look, typically we read it the other way around. So I'm going to apply a reversal. I'm going to put this negative 31 over 3 here. I'm going to reverse this symbol. Bring down the x, reverse this symbol, and bring this over here. And this is our final answer. And the way we'll write it is we'll write negative 31 over 3. It does not have an or equal to, so we'll put a parenthesis, comma, 49 over 3. It does have an or equal to, so we'll put a bracket, and we're done. This second kind of complex inequality has the word and. You're given two inequalities, this one and this one. And it's saying that both of them are true at the same time. Okay? So what we're going to do is we're going to solve them separately. Solve each one of them separately. Minus 2 here, minus 2 here, cancel. Bring down the 5x, bring down the less than. 17 minus 2 is 15. Divide by 5, cancel. X is less than 15 divided by 5 is 3. So we know that x is less than 3. Okay? Also, we know that x plus 4 is greater than or equal to 0. So subtract 4, cancel, and we get x is greater than or equal to negative 4. So x is larger than negative 4, but x is less than 3. And so what I typically do is I'll write this one, the x is less than 3 first. Then what I'll do is I'll do a reversal here. I'll reverse this symbol, and I'll move this to the other side. And now I wind up with x is larger than or equal to negative 4, but less than 3. So it's a number that's between negative 4 and 3. So we're going to go from negative 4 up to 3. We are equal or equal to with negative 4, so we put a bracket. We do not have the or equal to with the 3, so we put a parenthesis, and we are done.